Hello, I'm Quincy Wang. It is a pleasure to share our research and development project with you. I'm a doctoral student in Educational Technology and Learning Design at the Faculty of Education, Simon Fraser University in Canada. I have co-authored my presentation together with Dr. Cristina Campellani. She is an associate professor in Educational Technology and Learning Design at the Faculty of Education, Simon Fraser University in Canada. In this presentation, we will introduce you to the purpose of our project and theoretical framework. Then we will move on to illustrate the AR project that we worked on in a science museum in Canada. We will highlight the design strategies, methods, and the visitors' feedback on the AR project. We will also consider some future directions our work will take based on this project. We end the presentation by inviting you to play with the AR app that was developed. Our motivation for this project was to explore the possibilities of AR to support museum education in developing its exhibitions and learning spaces towards more participatory and interactive modes. At the same time, the educational opportunities of augmented reality are attracting increased attention among museum educators and curators as a novel yet largely unexplored technology to enrich museum experiences and to learn. Traditional, static collections of objects and exhibitions neglect visitors' interests and diminish visitors' possibilities for interaction with each other and the museum objects. To this end, we have explored the possibilities of AR reaching these goals. The theoretical framework that has guided our educational design with AR draws on our earlier work that will be published shortly. You can see the reference to our work in the slide. Briefly, our framework consists of 5 dimensions. First, AR affords accessibility to museum artifacts without time and spatial restrictions. Second, AR energizes immersive learning activities while providing novel learning experiences to visitors. Third, AR allows hands-on experimentation. Fourth, AR develops curiosity through visualizing invisible concepts. Fifth, AR fosters active engagement. Our AR project took place at the Science Museum. In this project, we designed and developed an AR application for a beehive exhibit. The Science Museum had strived to create more dynamic and engaging educational activities for visitors. The observation beehive exhibit was chosen for the AR intervention due to its meaningful educational topic and aligned with World Bee Day. The exhibition aims to raise awareness that the bees are under threat by humans and demonstrate how we can protect the environment and support the Earth's sustainability by taking care of tiny bees. The AR beehive exhibit is not a standalone exhibit for displays, but an educational space to ignite wonder, learn not to fear bees, and get into the beehive to understand more about the life cycle of the honeybee in all seasons, with no time constraints. The AR exhibit is easy to access through visitors' own digital phone cameras by simply scanning a QR code to acquire details of bees through their shape, roles, and performance. The creation of virtual 3D animated bees enhance reality, allowing visitors to use their fingers to touch and rotate different types of bees, thereby building a personal connection with bees. The AR exhibit enriches interactive learning experiences by allowing visitors to manage and interact with the learning content at their own pace, making the learning more authentic and salient. Our AR project was developed through a design-based research methodology. A design-based research methodology approach allowed us to iteratively inquiry, test, and reflect, thereby working closely with museum curators, instructional designers, and AR application developers to design an authentic AR-enhanced exhibit for a science museum. On completing the Phase 1 prototype, we conducted one-on-one in-person short surveys with visitors immediately after exploring the AR exhibit. The survey questions focused on user accessibility, user interface, and user experiences during their immersive learning activities. The results suggested that AR technology can enhance learners' engagement, foster their curiosity towards science, and help them become more self-motivated, seamlessly and synergistically to connect individual, social, and physical components. Here are some examples from the visitors' feedback. For example, AR is the bee's knees. It provides an alternative way for students to experience a similar sense of wonder to being on a bee farm without jeopardizing the safety of students. My students are ecstatic to learn about bees in AR. Our AR integrated beehive exhibit offered a snapshot of AR integration in museum education. Ideally, it can encourage those who seek to develop and transform museum educational spaces for interaction and learning. According to our experiences and learnings, AR contributes to museum education by creating novel forms and learning for visitors. At the same time, we argue that more research is needed to understand how AR can be used in museum spaces and the kind of practices, experiences, and learning opportunities it offers. In the future, more research attention needs to be given to diverse visitors and how their needs and situations can be accommodated through AR. Thank you.